In this video, we'll use series sum in the LINEST polynomial regression. Here we have an example of a polynomial, which is y equals x minus 1 times x minus 2 times x minus 3. Multiplying together, it becomes x cubed minus 6x squared plus 11x minus 6. In the spreadsheet format, it is y equals the series sum of the x values raised to the power 0 incremented by 1. And the coefficient starting from minus 6 is coefficient of x is 0, 11 coefficient of x, minus 6 coefficient of x squared, and 1 coefficient of x cubed. So we copy these coefficients. So x to the 0 is minus 6. Coefficient of x, 11. Coefficient of x squared, minus 6. Coefficient of x cubed, 1. So these values have to match this polynomial. Now we can use the series sum. So array formula. Series sum of the x values raised to the power starting from 0 incremented by 1. That's incremented by 1. 0 incremented by 1. And the coefficient will be this range. This will be the coefficient. That's from negative 6, 11, negative 6, 1. And we'll chart this. Insert chart. And we use scatter chart. Row 1 is header, column A is label. When show the series, show the trend line. The type, polynomial. The degree, we are limited to x cubed, so degree 3. For the label, use the equation. For the legend, position at the bottom. We don't need a title because we need a space. We already have the label. So here's our trend line and the polynomial. So this is y equals minus 6, that's minus 6, plus 11x, 11x, minus 6x squared, minus 6x squared, plus x cubed. We can use LINEST to calculate this. To do that, we can use the least square method, LINEST, for this one. We complete the LINEST matrix, starting with the elements of the matrix. So this will be array formula. Array formula of the x values raised to the power 0 to 3. Now we can use LINEST. LINEST y and x. So coefficient of x to the 0, minus 6. Coefficient of x, 11. Coefficient of x squared, minus 6. Coefficient of x cubed, 1. And we'll calculate these values using matrix. We begin with the P-Jarina inverse. So minverse, a mult, transpose of the LINEST matrix and itself, and the P-Jarina vector, which is a mult transpose of the LINEST matrix and the y values. Now we can calculate the coefficients. So P-Jarina inverse times P-Jarina vector is equal to a mult of the P-Jarina inverse and the P-Jarina vector. So these values are the same. That's minus 6x, 11x, minus 6, 11x, minus 6x squared, plus x cubed. So they are the same. So, and we go back to the zeros, the intersections, the roots. The roots are x equals 1, which is this, x equals 1, 0, 1 minus 1 is 0. So at x, the other root is x equals 2. If x equals 2, it's 0. And x equals 3, it's also 0. This completes the use of series sum in the LINEST polynomial regression of this polynomial y equals x cubed minus 6x squared plus 11x minus 6.